So today we're continuing on with 1.4. We're going to start with the explore problem. Haley wants to have $5,000 at the end of 3 years for college. All the interest rates that she has found are less than 10%. Determine two possible amounts that she might invest to reach her goal of $5,000. So $5,000 is her future value. Interest rates are less than 10%. 3 years is her time, or her the amount that she has, the time she has to invest. So we need to figure out two possibilities for how much she needs to invest to reach her goal. So here we have just one example of a possible situation where you have 1% interest compounded annually for 3 years. So then let's look at the investigate. In 5 years after graduating from college, Jessica wants to spend a year traveling in Canada's 3 territories. She determined she'll need $15,000 for the trip. She wants to invest money today. 7% compounded annually is the plan that she found. How much will she need to invest today to have $15,000 in 5 years? So what we can do here is we're going to plug these numbers into our formula, which is A equals P1 plus R over N to the exponent N times T. So we know her time is 5 years. We know A is 15,000. And we're looking for the principal. The rate is 7% compounded annually. So what we can do then is we're going to simplify what's in brackets first and then exponents because we're following BEDMAS rules. So we get 15,000 equals P times 1.07 to the power of 5. So 1.07 to the power of 5 is 1.4, which then we need to divide for both sides to get P by itself. So your principal on this plan is $10,714.29. That's the amount she would have to invest under this plan to have $15,000 in 5 years. So let's take a look then at the ratio of the future value to its present value. This ratio can be written as the future value over the present value. So the future value that we found is 15,000. The present value is $10,714.29. So if we divide these, we'll get our ratio. So 1.4 is your ratio. Now, the higher this is, the better. Or the better your investment is. So then we're going to look to example 1. We've got Joel, who is 18 years old. He inherited some money. He wants to invest it so that when he turns 30, he can buy a cabin that will cost $170,000. He's got 6.5% compounded annually lined up as a investment plan. So we need to figure out how much he'd have to invest today. So when you go through the steps, you come up with a present value of $79,846.09 that you would have to invest today. Then part B says, what is the ratio? So let's take the ratio is the future over the present. So the future value, which we actually write as A, is 170,000. And the present value, or the amount he had to invest today, $79,846.09. So when you divide these two, 2.13 would be the ratio. Then part C, we're going to do this again, but we're going to now calculate 6% interest semi-annually and do the new ratio to see which investment is better. So after this is completed, you'll get a ratio of 2.03 for the second investment and a ratio of 2.13 for the first one. So which investment is better?
The first one.
The first one, because if you look here, you only have to invest $79,846 originally, compared to here you would have to invest $83,628. So you can tell that the higher ratio does give you a better idea of which is the better investment. Then we have example 2. We've got Miss Marshall who wants to invest $15,500 in a registered education savings plan. She wants to grow to at least $50,000 by the time her newborn babies enter university in approximately 18 years. So which one will produce a future value of $50,000? What investment rate, sorry, is what it's asking for, compounded annually. So we want this to end up at 50,000. We're originally investing 15,500. Our rate is what's unknown. It's compounded annually. And the time is 18 years times 1 compounding period. So we end up here with 50,000 plus 15,500. So we're going to divide both sides by 15,500, and we're left with 3.23 equals 1 plus r to the power of 18. So how do we actually get something to the power of 18 out of there? How do we move that? Root 18. Good. So we actually need to take the 18th root of both sides to get rid of those 18s. So the 18th root of 3.23 is 1.0672, and that'll equal 1 plus r. Then to get r by itself, we'll subtract 1 to the other side, and you're left with 0.0672 equals r, so your rate is 6.72%. So now that we have our rate, we want to figure out time. So let's say that she wants her 15,500 to grow to at least 60,000 at the interest rate we just found. So now we've got 60,000 equals 15,500 times 1 plus her rate, which is 0.0672, still annual, times, or to the exponent of your time. So let's go through this in the same way. First need to divide by the 15,500. And you'll still get 3.23 equals 1.0672 to the exponent t.